Serway, Chapter 2, number 78. I read, a commuter train travels between two downtown stations. So let's call station A and travels from A to B. Because the stations are only 1 kilometer apart, so I'm going to call this distance between A and B x, and that equals 1 kilometers. The train never reaches its maximum possible cruising speed. During rush hour, the engineer minimizes the time interval delta t, that's a time interval takes from A to B, between two stations by accelerating at the rate A1 equals 0.1 meters per second square for a time t1, and then immediately braking with acceleration A2, that equals negative 0.5 meters per second square for time interval t2. Find the minimum time interval of travel t and the time interval t1. Okay, so let's try to understand what's happening in here. So first of all, the train starts at the station A, and initially it's at halt, so I'm going to call it V01 equals 0 meters per second. So why I'm calling it 01, because I want to split the station from A to B into two parts. So I'm going to call, I'm going to pinpoint or flag the point where the train has slammed on the brake. Let's call that point C. So and then I'm going to treat this problem as two separate problems from A to C and C to B. So let's call the distance from A to C to be x1, distance from C to B to be x2. Now, from point A to point C, the train is going to accelerate with the acceleration a1 in a time interval t1. When it reaches at the point C, I'm going to call the first portion, the final velocity in the first portion as a v final 1. Then right after it reaches the point C, it slams on the brake, and my second part of the trip starts, which is, I'm going to call it V initial 2. But we do understand that these two are equal to each other because we kind of artificially split the time, so the train is going by itself. Anyway, so at the point B, which is the station, the train is going to stop, so I'm going to call it V final of the part 2 equals 0 meters per second. Okay, so now I'm going to use that x equals x1 plus x2 and see what do I know about x1 and x2. It seems like I have lots of kinematics. I have lots of data, so I can use kinematics equations. So using one of the kinematics equation, I can write x1 equals v01 t1 plus 1/2 a1 t1 squared. It's important that we keep the notations accurate. So for the x2, I'm going to write x2 equals v02 t2 plus 1/2 a2 t2 squared. This one has a lot of, the x2 has a lot of unknowns, like v02 t2 are unknown. However, for the x1, v01 t1, this term is a 0 because v01 is a 0. So I can rewrite x1 equals 1/2 a1 t1. Now let's try to get the deal with the V02. From other hand, we know that V02 equals V final 1. So I'm going to go on a side and find V final 1. So from another kinematics equations, I'm going to say V final 1 equals V initial 1 plus A1 T1. So V01 is 0, so V final 1 is A1 T1. So I can plug that in. That equals A1 T1 T2 plus 1/2 A2 T2. So can we actually find the relationship between T1 and T2? Now we still have two unknowns. Well, let's try to use V final 2 equals 0. So let's write another equation, kinematics equation for V final 2 that equals V initial 2 plus A2 T2. Okay, in this case, V final 2 is a 0. So I have a 0 equals, and V02 is the same as V final 1. That is cool. So I can plug it in as a A1 T1 plus A2 T2. And then I'll get, what do I get? What do I want to solve for? I want to get rid of the T2, so therefore I'm going to solve for T2. That equals negative A1 T1 divided by A2. Okay, let's plug this one into our x2 equation. So we have A1 T1. Now plug in the T2. Negative A1 T1 over A2 plus 1/2 A2 negative A1 T1 over A2 squared. Let me just make a kind of a line in here so we won't get confused. So let's continue simplifying this. I have what do I have in here? I have negative A1 squared T1 squared over A2 plus 1/2. One of the A2's will cancel out, so I have A1 squared T1 squared over A2. This sounds like a good idea, huh? I'm liking this. That is negative 1 of something plus 1/2 of something is a negative 1/2 A1 T1 squared, A1 squared T1 squared over A2. Okay, so let's go back to our final point where we have the x equals 1,000 meters, which is the 1 kilometers, equals this guy goes down here, 1/2 A1 T1. Look at that, I forgot a square in here. Okay, and then I'm gonna just bring this other guy over here. So minus 1/2 A1 squared T1 squared over A2. So if I simplify this one, let's take the 1/2 A1 T1 squared out. I end up getting 1 minus A1 over A2. Okay, so all we need to do, plug in the numbers and solve for T1. So if you do manipulate this equation for T1 and solve for T1, you will get T1 squared equals 2,000 meters divided by A1, A1 times 1 minus A1 over A2, which equals 2,000 meters divided by 0.1 meters per second squared, 1 minus 0.1 meters per second squared divided by negative 0.5 meters per second square. Okay, so let's increase this one, and when I plug this into a calculator, I'll find T1 equals 129 seconds. Now, if we plug this guy into the equation of T2, then we'll get negative, what is it? A1 is 0.1 meters per second square times 129 seconds divided by A2 is 0.5, and we will get, let's say approximately we'll get 26 seconds. Well, the total time then equals T1 plus T2, that equals 129 seconds plus 26 seconds, makes it 155 seconds. So this is approximately 2.6 minutes. Is this reasonable? Well, according to my experience when I was traveling in a train from station to station in downtown, usually it takes 2.6 seconds, 2 to 3 seconds. So it is a reasonable result that I am getting. Okay, have fun with this.